So here are some examples of man traps. We have the revolving door, we have the turnstiles of different designs. So with a man trap, the individual is authenticated and then enters the man trap. The man trap generally has an entrance and an exit, and only one individual is allowed in the man trap at a time. And this can be through just reduction of physical space with the revolving door, or this could actually be two adjacent doors where the user swipes his card, walks through door number one, closes door number one, and only after door number one is closed can he unlock door number two with another swipe of his card. Very often these man traps have biometric devices installed to identify the weight of the individual and maintain that that weight is consistent with what the weight has been historically. This is to defeat the individual from removing property from the facility. Here's an example of a man trap. And again, if there were a weight sensor in the floor, we could identify that there was only one individual in the man trap and that the individual is probably not carrying away one or two computers from the facility. A couple of definitions you'll need to know regarding doors. We have the fail-safe configuration and we have a fail-secure configuration. Now this implies that if the power fails, what is the state of the door? If we say that the door is fail-safe, that means when the power fails, all doors are now unlocked. This is usually a requirement by local fire codes. Fail-secure says if the electricity goes away, the door remains locked. This very often is an unsafe situation. Next, we're going to look at external boundary protection mechanisms. These are physical controls that are placed external to the facility, and they are our first line of defense against an intruder. We're going to look at some locks, fencing and other physical barriers, security force, outside lighting, intrusion detection systems, and then monitoring devices. And again, our goal here is to stop the bad guy from ever making it to the facility. Let's start with fencing. You should know this table. The height of the fence has a direct relationship with the level of deterrence on penetration. A 3 to 4 foot fence will deter the casual trespasser. A 6 or 7 foot fence is too high to easily climb. What this means is if somebody comes over a 6 or 7 foot fence, he has malicious intent. This individual is determined to come into your facility. If you even want to stop that guy, you build an 8 foot tall fence with barbed wire on top. This is a severely determined individual. This guy really is somebody we want to keep outside. We have powered fences that provide an electric shock. Now generally this is a secondary fence. I'll put an external fence up that might be 6 or 7 feet high, and then I'll put a second fence that is powered. There should be signage that identifies and warns this is an electrified fence, because this could actually injure an individual and provide a form of liability for your organization. So powered fencing generally is a secondary fence inside an external peripheral fence. The next one we see on the slide is called the PEDIS fencing, Perimeter Intrusion Detection and Assessment System. Now PEDIS actually sends a small voltage radio frequency signal through the entire fence, and as an intruder might touch the fence, it changes the impedance of the fence, the way that the radio frequency commutes through the fence. This is detectable and signals an alarm. The problem with the PEDIS fences is that there are very high false positives on the PEDIS fence. If a tree branch falls up against the fence or an animal brushes up against the fence, you'll get an alarm. So a lot of false positives on PEDIS fencing. This diagram shows the implementation of a PEDIS fence, where the signal detection is inside the lamp post itself. But then a cable run, a buried cable run, would go from the lamp post where the detector is to the security guard center. Again, if an intruder touches the fence, an alarm goes off. Security guards now can provide a conditioned response to the perceived threat. The mesh of the fence and the gauge of the wire used on the fence has a relationship to the level of security on the fence. The broader the mesh and the smaller the gauge of the wire, the less secure and of course the less expensive. The tighter the mesh, in other words, the smaller the openings between the wires and the thicker the wire, the more secure the fence is, and of course the more expensive the fence is. In addition to the mesh and the gauge of the wire, you want to consider, of course, the height of the fence, as we discussed earlier, and putting this top guard of barbed wire on top of the fence. Many issues regarding fencing need to be considered. They require a great deal of maintenance and planning in their construction. So the fences need to be inspected on a regular basis and maintained on a regular basis. Of course, the posts have to be buried deep enough and always secured with concrete so that somebody can't simply just dig out the post and violate the fence. We want to be concerned about materials around the fence. A tree very close to a fence. A bad guy can climb the tree and jump over the fence. So we want to be sure that there aren't any natural or even construction type of objects that might allow someone to evade or violate the fence by simply climbing on top of a shed perhaps and jumping over the fence. We'll take a quick look at gating. There's 4 classes of gates. Everything from a class 1 being the lowest security level for residential usage, all the way through a class 4 gate, which is restricted access. And this is one that typically is monitored and uses barbed wire on the tops. Here are some examples of those types of gates. A bollard is something that provides the illusion or appearance of a fence. These are typically posts or other components, maybe even it's shrubbery, that provides the illusion of a contiguous fence. Even though there are gaps between these posts or bollards, it does provide a visual boundary for pedestrians. Next, we'll take a look at lighting. A handful of details we need to understand about lighting. Of course, it deters trespassers and bad guys because now they're exposed, they're visible, they're not stealthy. We want to provide lighting in all the critical areas where our employees and our customers might be, and there needs to be no dead zones or gaps, dark areas, in the areas where these pedestrians might be. I very often will combine lighting with my surveillance cameras, my closed-circuit TVs. Of course, lighting needs to be carefully planned out and installed appropriately. Again, the objective is no dead zones and coverage where my users and my pedestrians might need to walk. Let's say from the building to the parking lot, illuminate the whole pathway, illuminate the whole parking lot. So there are a handful of issues regarding lighting that we want to consider. When we install lighting, we want to see to it that the glare from the lights don't cause problems for closed-circuit TVs or for the guards that are going to be watching the areas that are illuminated. We want to have continuous lighting in all the areas where our pedestrians will be. We want to have no dark spots, no dead spots in the lighting path. We want to see to it that we're not illuminating areas we're not concerned about. So we don't want to be spending money and illuminating our neighbor's property as well. The last 2 on this list here deals with standby lighting. Now, standby lighting is where we might randomly cycle on and off lights inside a facility to provide the illusion to a bad guy that there might be people inside and therefore he probably doesn't want to break in. And then the last one here is responsive area or trip lighting, and this is where we have a motion detector that flips on a light, very much like we might have on the alleyway or at the garage in our homes.